So it's just a four. It's a four. Don't worry about me. So we've also got an additional member of the panel this evening, Ivan. Some of you might know him. He did actually sit on the first panel 5-6 months ago now. Ivan is one of the early pioneers in London of deploying container and microservices architecture technology. If I remember rightly, you were at AdBrain, and that's where you did a lot of your building. Almost 12 months ago you started, maybe 12 months, 18. And he's actually a MongoDB user as well, for you Mongo guys at the back. He recently went to well, in fact, I can let you explain what you did.
I've been working with containers for a while. What I do basically is to move legacy applications or application monoliths into containers. Yeah, that's basically what I do. Yeah.
He's basically here to tell you what it's like to run containers in production at scale. So I'll kick off. Thanks very much, guys, for the fantastic presentations. Really, really interesting stuff. So first question I've got, obviously now that we're entering into a world of containers, the operating system is obviously going to evolve from here. What do you think the main things are going to happen to the operating system are? I mean, I saw an article yesterday saying the operating system might become, less important. Do you think that's going to happen?
Yes. If you look at things like Mesos or Kubernetes, basically taking away all the power of the OS, and I'm sure that the guys from Microsoft or Ubuntu, they will not agree, but it's what's happening. For me, the value doesn't come from the OS; it comes from what I run in that OS. But I'm sure that people will think differently.
Yeah, I mean, in a sense, the value's always been in the app on top. Like, the operating systems are really uninteresting. You heard it from me. Operating systems are truly uninteresting. What's really interesting is what you do on top of them. And the real trend is all scale app. Now we have no Microsoft here. It's really easy to say this. The real trend is that all scale out applications have moved to Linux. So, and then when you have containers that allow you to run any Linux on any Linux, well, suddenly, any app can run on any core. And so the lock-in of a Windows ecosystem just isn't that important. Does it make the OS irrelevant? It makes it less visible. I don't think it makes it irrelevant. So just like if you think about what happened when we moved to public cloud, like why Ubuntu right now, we're 70% of all the images on public cloud. Okay, so there are lots of free OSs. Why would one OS do that? Well, it turns out that thinking about what the nature of an OS in a new world is really important. So for us, it was looking at init and saying actually cloud init was really important. There were lots of things that we could do that would make the OS better for a new environment. And I think, so the same thing that held true for going to public cloud, where it turns out that it doesn't matter if you're Heroku or Instagram or Netflix, you all choose the same OS. Actually, some tasteful, cleverly done things in the container space will make the OS itself better for the container world. And hats off to CoreOS. I think looking at transactional updates, that was important. Really small images was important. So I don't think the OS goes away, it evolves. But I would say that.
Yeah, I would tend to say the same. Well, I hope we'll have less OS in the sense that they're going to shrink a bit because there's tons of stuff in there. And I guess everyone would want that. Then maybe we tend to move to a model where, again, going back to a model where you have different flavors of OSs based on what you're using them for. But what I think is interesting is also that in the Linux world, there's kind of a renewal of maybe new project and new ideas at the system level. Whether it's going to be less OSs is interesting, but obviously CoreOS is very interesting. It's a new Linux distribution. It's been a long time, and I think for the whole system ecosystem, it's interesting to have new ideas, new players. And I don't know, I think we all want to have less layers and thinner layers and less complexity. If we can reach that, then good, but not sure.
Okay, so I don't know what kind of a panel it is if we all agree. But yeah, So talking about CoreOS, I think it's a very cool thing, and just taking away the pain of updating all the underlying stuff. I think that's very important. So I would like things to be more high level, so where you only have to think about apps, but on the lower level you have to trust that things are okay. So yeah, I think it will still be pretty important, but probably it will not be the focus in the future. Yeah.
Is there any comments from the audience on this at all?
Isn't this just a matter of what you call things? Because you kind of have what an OS does somewhere in the stack. You can't really get away from that. How you cut it and what you call different bits. But ultimately, the hypervisor becomes the OS, or the container level becomes the OS. You might squeeze out something like Windows, which kind of gets squeezed from both sides and suddenly becomes irrelevant when you can suddenly run containers on your hypervisor, for example.
Anyone want to respond to that?
Is that not? Is it not just a matter of terminology?
I think it's a bit more. I think in truth, there's a bit more to it than that. OS is not going to change. And CoreOS showed this. Does everyone know the background of CoreOS? It's basically Chrome. And I talked earlier about feeds of data center things coming into mobile consumer electronics coming into the data center. The same thing that applies to CoreOS, Chrome,
Something that you said, that the data center is becoming like it's learning from the mobiles. All the non-technical people that I know, they don't care about the OS that their mobile is running, right? So that's the answer. People don't care about these things, and the only thing that they notice, like, oh, now my telephone is slightly different because it looks different, but I don't really know if it's not running this process like this, or they don't care, right? And that's the thing, that it becomes completely transparent. And that's basically what we want to have with Mesos and Kubernetes. We want to abstract that. Someone else has to take care of that. I don't like what CoreOS is doing is fantastic. But you know what? Like that I don't have to do my upgrades and updates, fantastic. But you have other problems that we will have to deal with, right? But to me the OS is becoming less important. That's why it's free.
Okay, so obviously we're starting to see more people deploy containers into production, and obviously OS is part of that. And we're going to see that sort of the number of these projects grow. We're going to see people start to grow the number of containers that they deploy into production. What do you see the main challenges being from the pure operating system level or the infrastructure level when it comes to scaling these types of infrastructure? Would anyone like to take this?
Okay, one of the questions that people ask me is how many containers you run in a machine, and I say it depends, because that's the standard answer you always give. It depends. It depends on the machine that you're running, but usually you run around between 7 and 20, depending what you want to do, right? Like, what happens if you run many more? It is okay, but then you get the problem of not knowing what you have where, and that's a problem we have to solve. We solve with console or with this kind of, but we have logs monitoring and knowing all these services that we run, that we still have a little bit there in the edge. But yeah, it's a problem that I see, that when you have a machine and then I have to decide to run these 20 containers there, it's like, why in this machine and not in that one? And that's why Kubernetes or Mesos takes away that pain. Right? That you don't worry about, I have to go and put this in this machine, in that machine. I don't want to make that decision. Someone else smarter than me has to do it, like software. But yeah, it's my experience with that.
Yeah, I think that there's this problem with knowing what's going on, and in some ways Kubernetes or Mesos, they are doing a lot of magic that is great when everything works. But of course, you also lose some kind of visibility of what's going on, and it's a challenge. It doesn't mean that it's not a good trade-off, but it means that developing tools and processes and knowledge around visibility of what's going on. It's an operational issue, right? It's some of the issues you have with virtualization when you have VM sprawl and tons of templates. You get them with containers, maybe even more, right? The number of different images and so on. Tracking what's going on, it's going to be a great challenge. And I think that there's going to be tooling, but it's going to be a lot about the processes you have and how people work together and the kind of workflow and the kind of tool chain you have.
Can I ask something? How many people are running VMware like a big scale, more than 100 VMs? Do you know in which machine the VM is running? Do you care?
Sometimes. It depends.
On that point,
Yeah,
on that point, I do have a lot of issues because I'm not an expert in content, but I work with a lot of projects in Africa, and they have a sort of sense of ownership. They would like to see the server, so I've been asked like, they want to visit this cloud, they want to see it. So I mean, I think there's a lot of it's quite true what you mentioned. I don't know how we can help in that area.
I don't know.
I think there are contractual and compliance reasons why you might want to know where your code is running. Compliance reasons like you have to run in a certain territory or in a certain data center.
Yeah, but
Contractual
that's
reasons
some
like
zone issues. But that's something different, right? Like,
they're not technical issues.
like UBS, for example, if you're dealing with Swiss data has to be in Switzerland, right? And you have to guarantee it, blah blah. But that's something different. That's not the point. The point is that if you have, I don't know, 100 blades, and you have, I don't know how many VMs running in all these blades, and like you have a problem with this VM, you will not, you're like, oh, I have to go to this machine and press this button. Of course, if someone does that, you will going to have a big problem, but you don't really care in which machine is that thing running. You know in which VM, and that's something similar to this. Like, what I want is to, you know what, abstract that. I don't want to care about where my container is running because that's not important. It's very important all the stuff happens around that, but it's not important. It's like it's in this machine here. Don't switch it off, please. Right? That's.
I think because I work for a company, we run different services for different customers. We have one or two customers who are quite picky about where their service is being run, even though it's the service that we're running for. And we're trying to convince them of what you're just saying. It doesn't matter. You're sharing this platform. It's got a bunch of blades. Stuff runs all over the place. It doesn't affect your service in any way.
Yeah,
and that's still something that we're trying to
say.
say.
Machines that these guys are using, and then like, well, the VM is in one of these two machines, but they don't know in which one. Right? Probably. We will end up all in that same place because that's what happened with when we moved from metal to virtual machines. That's what we got, and all the projects that we went through, all the sysadmins are like, oh, you're crazy running in VMs and it's not going to work. Oh yeah, it won't. And then, oh, you cannot put Oracle in VM. Oh yeah, you can. And it will happen the same with containers. It will happen. And Kubernetes and Measure is the first step towards that.
Thanks. Any questions from the audience?
So is there a reason why you wouldn't run Docker on bare metal?
The question was, is there any reason why you wouldn't want to run Docker on bare metal?
I think it's a huge can of worm because it's also asking, is virtualization going to disappear? Now we have container and so on. I mean, personally, I would say I hope so. I think that virtualization is kind of a workaround. Someone say, I think that must be someone from Sun to say something like that, that the widespread usage of virtualization is just something that show that the OS weren't sophisticated enough. And there is some truth in that it's been a workaround for some issues. It's become, every solution in the software world becomes its own problem at some time because it's grown, it's been so successful that it's difficult to avoid now. And we have processes, we know how to work with it, we have an operational culture around it. So it's difficult to get rid of it, and it's going to be difficult, just like you said, moving a database to a VM. That's crazy. That was crazy a few years ago. And so saying now it's the opposite, right? Running containers on bare metal, but you're crazy. How are we going to manage that? I hope that we have more, and it's interesting what Canonical is doing also with a separate, different type of container for other type of processes. I hope we get rid of it and we go back to having one layer, at least at that level. Well, that's the side effect, but they might move to the container world. I mean,
I'm interested in the NXT stuff because we run 4,000 containers at the moment on bare metal machines.
Yeah. So the simple answer is we totally. Oh, it is on XD.
It's on NXC at the moment.
Okay, so we should definitely talk. I mean, no, in a sense, the use case is absolutely real. So if you think about it, there are whole sets of workloads that it's not interesting to virtualize. Just from an overhead, the hypervisor gets in the way, it creates overhead. It's blind. One of the VMs asks for something, it interrupts the kernel has no way of working out which VM should have priority or very limited view on it. If you want deterministic, predictable behavior from a set of guest images, the beautiful thing about containers is you can start having one set of decisions about what should have access when. You get much better performance. It's basically bare metal. I'm talking to a large service provider right now, very, very large one, and they offer bare metal. You log in, you get your server, which is great, but it would be really nice if you could move everything from that server to another server with live migration. It would be really nice to know that when you get given that server by a large service provider, that the previous user didn't have the rights to go down and update the firmware. That's what using a lightervisor suddenly gives you. You have the behavior of a virtual machine with the density and the performance of bare metal. We think this is absolutely where a lot of things go. What's the big drawback of all this stuff? The big drawback is you don't get Windows and Solaris running on Linux. You are locked into a more Linux world. Although having said that, frankly, the Microsoft guys get a lot of credit. They are tracking a lot of the work around. We're talking to them, and they're tracking a lot of the work around container APIs and trying to be as aligned as they can be. But I mean, there are things that the the virtual machine world delivers that containers aren't going to get to in the shortly. Just one more. You said of problems. One problem that we're certainly identifying is when you're dealing with tens of thousands, hundreds of thousands of containers, there are networking issues. We announced a project. Anyone who's interested in that, there's a project called FAN, which is our view on doing enormous numbers of containers to containers within a particular public cloud environment and making sure you've got enough IP address availability. So we do think there are, it's an example of a problem set. Again, no one cares about the OS, but my word, when it breaks down, it's an issue. So FAN is a project worth looking at. Sorry.
So to sort of give my low-level view on these things, I don't think containers are a security technology, and I don't think they will be in the short, mid-future term. So I'm really interested on this micro, how was that, like micro virtualization or something like that. So I will be very interested on seeing how that actually works. And you said that it's coming like in the next couple of years.
So that way you can. Do you mean integration with silicon or?
Yeah, that's what I'm interested in.
You'll see. So if you put up the slide with the clear
work from Clear Linux from Intel. So yes, it's a lot of that work, and you'll see it landing and silicon and software coming together next year.
Cool. So just moving on a little bit, there's been a couple of people mention how they deal a little bit with security. So we've had AppArmor, SE Linux, and so on. Do the panel have a good idea as to what the best way of approaching security is, and where you see sort of the future of container security going? Yago, do you want to start?
So yeah, security, that's like very hard. So of course, the more layers you put, the more security you can have. But as I said before, so there are like exploits coming all the time about containers, like, oh, now I can break of my container. So that's gonna be very hard because the Linux kernel is not. It's not a microkernel. It's not something very small. It's not a hypervisor. So it's gonna take a long time. And even though I think user namespaces, for example, help a lot, And yeah, using Nestle Linux or AppArmor also helps a lot. But I still wouldn't trust that very much. So yeah, I really don't know how the future is gonna look like on that term.
Well, the future is going to look better, of course. Yeah, I think that security is not just a feature, right, or any technology. So obviously, container, the level of isolation is not the same as for virtualization. So first, I mean, if the baseline, the assumption is comparing it to VMs, then yes, it's not as secure, and there's a lot of different components that are involved in that. So it's going to depend what your use case is, right? If we think public cloud multi-tenancy, then it is a big problem, right? Then on your infrastructure, depending how you divide your environments, then you can manage it differently, right? I think multi-tenancy is an issue because that's where you have absolutes in terms of data separation and what doesn't need to happen. If it's all your stuff running and you don't have legal compliance issues, then you can make different trade-offs, right? So from a technical level, of course, there's a lot more to do, and it's going to take some time, but it depends also on your use case now, what you can do or should do.
Yeah, so I did agree with everything that's been said. I would want to differentiate two things. One is there's a set of security problems in containers themselves and what happens when certain processes break out. And frankly, as an ecosystem, we will resolve these issues. Like, it will get resolved. There's a separate issue from a workflow perspective that's worth thinking about. As you think about your organization, and I sort of touched on it when I was talking, which is, as a team, where do you get code from? Like, for your infrastructure or for your application, if you are a startup where you're writing all your own code, it's all open source, you don't get any ISV code, that's great. You know, you are masters of your destiny and it's going to be okay. If you're working in a bank where, frankly, you're taking lots of microservices from lots of different people and teams that you've never met are responsible for critical microservices that you've got built in your infrastructure, well, are you just going to accept them sending over Docker files to you, or is that going to be an issue? Do you want to have a bit more visibility? And so there are technical issues in the stack to solve, and then there are a whole set of working processes and honesty about how DevOps you're about to come, as go as an organization, which really require thinking about. And it doesn't matter if it's an external ISV or frankly just a development team that is not one that you totally and utterly trust with your running application. They're two different problem sets that they'll both get resolved, but they both need thinking about separately.
I will be a little bit naughty now, and I will say, like, the solution is very simple. Oracle shows the way. We just have to have an SLA that says that you cannot do it, and that's it, right? I don't know if you read the news today, but Oracle basically trolled the wall saying that, oh, you cannot decompile my code and come with all this stuff. But it is true about the hypervisor. In VMs evolve a lot, and it's very secure because of that, and it will happen with Docker and with containers. So that's something that it will happen. It's a trouble of being very early in this technology. I'm not worried about that. Your point is basically the critical bit. It's not about someone crashing my Docker daemon and me losing all the containers, because it can happen. Like, someone can crash my machine and I will lose all my VMs. That's something that can happen, but happens very infrequently. It's more about what happens with what I'm running that. And it's a long discussion we have in DevOps about how to manage this and source codes and building images, and there are different solutions for that. And I think it's for a different kind of talk. But yeah, if you want to grab me later, we can talk about that.
Any questions from the audience? Matt?
Yeah, I mean, go back to you were talking about being sure about what you're writing. That's actually where the nail file system is actually quite advantageous, because it can enable you to find out what's changed. So Jerome, who one of the guys at Docker, has actually shown how you can almost do the diffs between those layers to work out, when I'm running this third-party code, do you know what does it really do? And you can diff between effectively two images and look at what's changed and be quite specific. And that's actually pretty hard to do with VM, of course. So actually, there are kind of ways to do it, but then I think some of the stuff in the app-C and run C type runtime, I think is really for like code signing, so you can be absolutely sure of what you're getting. You actually, yeah. So you're right, it's kind of getting there, but I think some interesting things in there already.
Yeah, Docker is getting there too.
Yeah, it is.
With the new registry, they also have hashed images, and so I think that's cool because I guess they meant to do that, but having the AppC and Rocket to push a bit more, maybe that got thing that got
always good.
yeah.
That's just a bit of friendly competition.
Yeah.
Dry it, you know.
But the key is the registry, all the different registries you can have, right? So my experience is that if you have only one registry and you have developers building images, then you will have a problem. But if operations or whoever owns that building process and developers develop, push a code in GitHub or whatever place, and then is someone who basically is in charge of getting that and building the image and like, you know what, I'm someone who knows and I understand what I'm doing, and then I publish that into my registry. And one of the best way of doing it is like we have a registry for developers and we have a registry for production, and what goes to that registry is basically my Jenkins approach, and it's completely under control. We don't build Docker images just in my machine and push it there, right? So you have, but it's like people building jar files and pushing them. Now I was just like, I don't know this jar file or this Word file, and I run it in my machine, and then I destroy my network. Well, you know, it's the same thing. As operation, you have to make sure that you can block that, and we know that asking them politely, don't do it, will not work. So best thing that I found is to have different registries.
I think that's critical. Like the process you have to build your images and use images that you get from third party is going to be critical, because it's true that you have the layers and you can look at differences, but currently the tooling for container images editing is not necessarily really mature either. And in any case, I mean, I think if you have a large environment, you will have the private repositories, whether it's packages or whatever. You have to have a minimal of process for that. And it's true that in some ways, something as easy as moving around a container image can give you bad habits, right? Because you could attach it to an email and send it, and that's your process. Well, if you do that, then you can expect to have bad surprises, of course, and you'll have to make an effort to build this pipeline, definitely.
Cool. Well, we did start a little bit later than usual, so just to sum up, are there any closing thoughts from anyone as we leave tonight on the back of our discussions?
I think that we're in a really interesting situation now because we have a lot of momentum coming from containers and a lot of resistance from big companies because everybody's scared. And I think we have to bridge that somehow. And yeah, tooling is one of the ways. The other one is DevOps trying to change the process. But we all know that dealing with people is hard. So it's going to be interesting. To me, it's not as much as a technological problem, but finding the way around the landscape and humans, yeah.
A parting comment. I was going to say that my favorite use of containers, often when we get a new technology, everyone looks at it and says, what does it do better than the old? Like, what does it replace in my existing technology? And that's certainly interesting. But what's super interesting is when it does something that you've never been able to do before. So yes, agility, and yes, speed, and yes, density. These are all exciting. I love the Amazon Lambda service. Is anyone familiar with this service? So literally, it's a service designed at IoT developers, and you say, I want to dump data off, I've developed a new robot and it does this, and I'd like it to report back to a cloud. And AWS have rolled out a stunning service that basically, until you've sold 1 million of them, it's virtually free, and then you start paying a lot of money. And it's a really good way of getting everyone who's developing robots and drones to start with AWS. It's a great service. But the stunning thing is what actually happens there. You develop a robot, you put it out there, a drone, and someone turns it on a month later, and it decides that it wants to send some data back to AWS. That packet goes from the machine back to AWS, is captured, and they spin up a container with a virtual machine to process it, and then they close it, and they kill the container. Literally, the container is created for, a millisecond to do one transaction and then killed. And that's the use of containers for things where you would never dream, and you can't fire up a VM fast enough. You'd never think about using it that way. So we're all in on containers, but the really interesting thing is not just how do we cannibalize existing infrastructure, but how do we use it for totally new use cases. Anyway.
Another aspect I think it is interesting is that I saw in big enterprise customers suddenly a lot of interest in Docker, right? Not as a product or anything, but very quickly, in a matter of weeks or months, people were testing it. I don't think since tools like Puppet, I've seen such quick adoption in large enterprises and bypassing any processor they had in place, of course, because that's how it happens. And I think what is interesting, we discussed that with Matt, is that it's something that partially answers issues that are faced by developers, by platform engineering people, by operation people. So it's not a silver bullet and it's not a miracle or anything, but it's true that it's a technology that is at the crossroad of all these issues, and it's a great opportunity to have people work together. We talk about DevOps, for instance, and really address these issues that are still here years after years after years, and it's a great opportunity for that.
Yeah, when I heard what you said about this container that lived like 1 millisecond, I remember this Pantheon. I don't know if you know what it is. It's like basically a blog hosting company that just uses socket activation to start containers when you get the first connection to your blog, and then they just dropped it. So most of the people don't get accesses for the blog. So it's basically all empty, except when you get a connection. So that's a pretty cool thing. And yeah, back to the general thing. I think it's a pretty interesting. It's pretty interesting time to live this shift in the DevOps way of working. I don't really know much about DevOps, but from what I heard since the beginning of the year, it's very, very, very interesting. And yeah, I'm really glad I heard you guys talking about this stuff, because yeah, it's very, very interesting. So yeah.
Thanks very much, everyone, for coming. There are plenty of beers here if you want them, but we're going to head over to the Market Porter in Borough Market, so that's 9 Stony Street if you want to join us there for a few drinks, and I'm sure some of the panelists will be around to answer any more conversations afterwards. But thanks very much for joining us, and we'll see you on the 15th of September. Thanks.